We'll start with the simplest plot, the scatter plot, which is what you get if you use the plot command and provide R with a set of X values and a set of Y values. And in this case, we're going to use the warfarin dataset. So we start by reading the file warfarin.csv and putting the contents into the object D. And this is what we'll use to get data for our plot. And first of all, we'd like to make a scatter plot demonstrating the association or relationship between doses and the age of the patients. And those are stored in two separate columns in the dataset, column dose and column age. And we write plot $dose tilde $age. And $dose here contains the Y values. These are the X values for the plot. And this is what you get. A rather crude plot with the age on the X-axis and dose on the Y-axis, and the limits or the ranges of the axis are automatically adjusted to fit all values into the plot. And the labels here on the axis, that's simply the names of the columns that you're plotting. If you'd like to, you could write the plot command like this instead. Instead of using the tilde sign, you could give them the ages and doses as two separate arguments, but then you would have to give them in the opposite order, starting with the X values and then the Y values. Why this syntax takes the Y values first and then the X values. The reason I prefer to use this syntax is simply because this conforms very well with the way you write functions when dealing with statistics, for example, in linear regressions. But if you prefer, you can of course use this syntax instead. Next, we'll try to tidy this plot up a bit. And first we'll look at these labels here. And if we want to change these labels, we use a number of arguments. The first one is main, which is the main title of the plot. And in this case, I write main equals warfarin, and then we get warfarin written here above the plot. Then we have the labels here, and they are indicated by the arguments xlab, which stands for xlabel, this one, and ylab, which is this one. Next thing we'd like to look at is the ranges of the axes, because we may want them to start at 0, for example, which they don't do now that they have been chosen automatically by R. And to change the ranges, we use the arguments xlim and ylim. And xlim is of course the limits of the x-axis. And the value that xlimits needs is a vector containing two values, the start and the stop. In this case 0 to 100, and we have 0 to 150 on the y-axis. One thing you should keep in mind when changing the limits of the axis is that all values you're plotting may not fit into the plotting area when you change the limits. So in this case, if we, for example, would have set the y-limits to 0 to 50, then all these dots would not have fitted in, and you would not get a warning that you have data outside the plot. Next thing we'll look at is how to change the dots themselves. And here we would like to make them somewhat larger and filled rather than circles. And to make them filled, we use the argument PCH, which is short for point character, and then a number. Number 19 is a filled circle. I'll show you all the symbols on the next slide. CX is short for character expansion factor, and the default value is 1. And by choosing 1.5 we get points that are 50% larger than the default value. It's not easy to see, but they are somewhat larger. And here are the different point characters that you have access to. Now there is 25 of them, and the default one is number 1, a circle. You may notice that these 5 look quite a lot like a few characters at the top here. And the difference is that number 21, for example, when using this point character, you can change the filling color and the border color independently, which you cannot do with number 1. I do not know why they have chosen this design in R, because in my eyes number 1 is superfluous when you have number 21, which can do everything that 1 can and more. But this is the way it is. And you only have 25 of them, but if you bypass the PCH argument and use another technique, which we will look at later on, you can of course use any symbol that you have on your computer, any symbol, character or digit as point character, but not by assigning a number to PCH in the plot command.